1 drop, 2 drops, 3 drops of water. Right, we're on water. What a great subject. I've been fascinated with water, and I can't even say it properly, water, all my life. I'm still really fascinated with water. It was the first sentence I ever put together was involved with the fascination of water. Apparently I was crawling over the edge of a fish pond, just about to go head first in, and my Auntie Frances, my mum's sister, grabbed me by the nappy and pulled me back, and I put my first sentence together. I was only looking at the shishes. It was a fascination with the water, I'm sure. Water has the most unusual qualities. The world is shaped by water, and the fact that it expands as it freezes. It's most dense at about 4 degrees. It can't be heated above 100 degrees. Doesn't matter how hard you try to heat water. It starts to steam, and the evaporation cools it, and it retains that temperature. It's hard to clarify exactly what water is exactly, because it's nearly always got some life in it. It's very hard today to find reasonably pure water. There is a term called potable water. And the World Health Organization classify 2,000 different elements that should not be in drinking water at a certain percentage. So if you want to classify water as potable water, then you really have to do 2,000 individual tests, because there's no broad spectrum tests that test them all, to say that that water is something you can bottle up and you can sell it. And we can't find any of that water. It's gone. If you do find a piece of land with some clean water springing out of it, buy it, because you've just bought something a little bit better than a refined petrol well. It's much better than an oil well. Definitely swap you a litre of crude oil for a litre of water. In fact, if anybody wants to, I'll swap you a litre of petrol for a litre of water, because it's more expensive. Everywhere in the world. Just about everywhere in the world. It's probably cheaper to buy water in Iraq than it is to buy petrol, because last time I was in Iraq it was 1 Australian cent a litre for petrol. But most places, and everybody was selling it on the black market everywhere, but in most places you'll find that petrol and bottled water in the last 20 years are at least equal, if not water is more expensive. It's kind of interesting, because here in Australia there are 2 things that we definitely, and they're related, there are 2 things that we definitely lead the rest of the world in understanding, and that is roof water and collecting rainwater off roofs. There's no point in going into that in great detail with your average Australian. We all know what you're talking about. And the other thing is earthworks uphill. putting dams in up on the side of hills and putting earth dams in, earth-sealed dams. We understand that, and since the 1950s, our earth movers have been moving higher and higher up valleys, putting dams higher and higher up in the landscape, trapping water in difficult places, and doing a very good job of it. It's because we're in such a we're on the driest, flattest continent on Earth. But if you talk to most people about that, they don't understand how you can build an earth dam at all. They don't understand how the hell you can put it up the side of a hill or on the top of a hill. And they definitely don't understand anything about rainwater. The usual reaction is, ugh, rain? Are you going to drink water off your roof? Yeah, and we prefer to, actually. Most Australians realise that they'd rather have rainwater than tap water. We go the other way around. You go, oh, are you going to drink that stuff coming out of the tap? You know? You don't know what's in that. It tastes horrible. Everybody else in the world is the other way around. They're really shocked that you can drink rainwater. And in America, you always get the same. When you start this in the course, you get a hand goes up, a couple of hands go up, every time. And there's two questions that come straight away. I usually jump in front of them and say, you're going to ask me this. Right? You're going to ask me, do you have to filter it? And how long can you keep it before it goes off? Yeah, and it's hard not to laugh because you think, whoa, you don't really know much about rain, do you? And even in cities, it's reasonably easy to clean up the rain if there is something in the rainwater, and it's easy to tip off quite a lot of the rain on the first flush of rain. And if you understand a little bit about alkalinity and acidity, you realise that if the pH is reasonably close to neutral, there's not going to be too much in the water that's dissolved and water soluble, and that's why we have a tap coming off the bottom, not right off the bottom of a water tank. We have a tap a little bit up from the bottom to allow for a certain amount of sediment and to try this matter to settle out. A lot of people know that all you need is a little bit of limestone in a tank to adjust the acidity, or if you can't get limestone, a bag of oyster shells will do it. That'll even, correct your acid rains situation. So don't be surprised when you really got to talk people into roof water collection outside of Australia. And there is some history in some places. In the Texas Hill Country, everybody had what are called cisterns at one time, and they collected roof water up there, but they've taken it out. And you can find very bizarre situations where you would think it's very, very obvious that you should look at collecting roof water, but people don't. So don't expect people to not take on an obvious activity. I was working in Manaus. I've taught 3 courses in Manaus in central Amazon, and Manaus is a city right in the middle of the Amazon. It's the largest city in the state of Amazonas. It's where the Rio Negro meets the Solomones, the largest confluence of 2 rivers in the world. And Manaus has 1.5 million people. It's quite an old city. It was the richest place on earth at the turn of the century. It was the only place that rubber came out of. It was extremely wealthy. People used to send their laundry to Paris and back from Manaus. And they built an opera house in Manaus, which is an absolute identical copy of an opera house in Paris, still there. People like Pavarotti go and sing there now and again. But now it's an enormously populated city, and it has a lot of poor people and a lot of favelas. And there's the normal first world toxicity. It's a free trade zone, in the middle of the Amazon, so people are encouraged to put factories there and employ all the poor people that are walking out of the jungle. And it gives them an economy to fly supplies in and fly manufactured products out, so it's a bit bizarre in some ways. And there's not a lot of pollution control, so there's a lot of stuff getting dumped on the surface. And there's a water table about 80 foot down, about 27 metres down, there's a water table. It's in a 2 to 3 metre rainfall, surrounded still by quite a lot of forest, not far away. And most people are pumping water from underground. And even in the poor suburbs, people are paying $2 for 20 litres of water pumped out of a bore pump, and they're put in around poor suburbs, and all the drinking water comes from underground. But you can buy bottled water at about the same price, about a little bit more expensive than the price of fuel, and people do buy it, and yet there's 2 to 3 metres of rain coming down every year, and there's enormous rainfall. And when I walked around, tried to explain this to the students, and walked around the classroom, paced out the size of the roof we were in an agricultural college, and just the classroom we were in, and there was about 18 classrooms, was catching $1 million worth of water every year if you bottled it up. It's surprising, 1 cubic metre is 1,000 litres of water. 1 cubic metre, decimals, great, sorry for all you imperial people who are still stuck in the imperial system. It's kind of funny, you go work in America, you have to go back to like pints and gallons and then slightly different gallons, yeah. Yeah, 1,000 litres in 1 cubic metre, so you measure out your square metres, and if you've got 2 metres of rain, you've got 2,000 litres of water falling on every cubic metre. And there you'd have up to 3,000 litres falling on every cubic metre, on every square metre of roof. And you're surrounded by the largest forest on Earth, the largest tropical forest on Earth. Even though there's a bit of industry around you, it's pretty clean rainfall. And yet and I went out, it did rain quite often when we were teaching, and there was no gutters on the roofs. Most of them didn't have any gutters, they're just running out, creating great big dents on the ground and trenches. And I went out with a cup, and put a cup underneath and drank it, and it was a bit like Bill's story, everyone sort of went, like, it's rainwater, it's like, no, not that. And actually in Louisiana, the last time we were in Louisiana, last year, we actually got, Andrew was with us there, we were evacuated by Hurricane Ivan. We spoke about this, and talked about rainwater, and everybody was, it was a very disturbing, worrying thing, and there was flagons of water that people had that they were drinking, bottled water, bought water. So I didn't tell anybody. I took one back to where we were staying and filled it up with roof water coming off the roof, and took it back in the classroom the next day and put the cap on it and put it on the bench. And everybody drank it, and when it was finished, I told them it was roof water. And they were really disturbed about it, that they'd drunk this roof water. I'd actually done them a favour, I think. And mostly American students, some South Americans, Mexican, everybody else was local, I think, North American. It's a funny thing that we don't trust that water, and if you can find a spring water somewhere that's coming out of the ground, you should, if you can afford to, get those tests done. If it is bottleable water, it's very, very valuable today. But we should look at roof water as well as being something of great value. There are rain farms now in Australia. There are people covering large landscapes with plastic and collecting rain and bottling it up. You can buy rainwater as a bottled product. It's advertised as rainwater, particularly in areas of really clean air streams, extremely clean air streams, where you don't have to treat it at all if you have to anyway. And there's a great story about the water that was sold to the Seoul Olympics when the Olympics were in Korea, and there was a gentleman got the contract to supply the bottled water for the Seoul Olympics, and he was a Tasmanian from the west coast of Tasmania, which has the cleanest airstream in the world, and he was from Xi'an, which is right on the west coast, and he rented the football stadium roof, which nobody else wanted to rent, so it was pretty cheap. You should look at renting roofs. Right? And he just put in a large tank, which he filled with sand and made into a sand filter, and then put the rainwater off the roof through the sand trap filter into a normal water tank, bottled it, put a label on it, shipped it to Seoul in Korea, and he supplied the full Olympic contract, and he made more or less a retirement figure from pretty clever, actually. There are many, many roofs that are not harvested that will be harvested. They will be harvested. You will see this happen everywhere in the world. I'll guarantee it. We are running out of clean water. We are abusing water everywhere. All future wars will be over water. Many wars now are over water. And if you go to the scenarios that are the most extreme, you can see it now. And you can track the health records very easily. If there's something wrong with water, you'll pick it up in the health records and you'll get back to the water quite quickly. And if you want to get sick, the quickest way is with bad water. And wherever you are working, you must be very careful about the water you drink.
Geoff, one concern would be being confronted with lead-based paint on metal roofs.
Lead does not dissolve in water. Ask any fisherman when he's casting out a line. It sinks to the bottom, and lead.
But what about particles coming down the roof?
The heavy little particles sink in water. Everybody understands the pH scale. Everybody understands what acid rain is. And you really need to get to 4.5 on the acid scale before heavy metals dissolve. Up until then, they're particulate matter that sink to the bottom of a tank, or you can tip them off. So large amounts of organic material could be a problem. Heavy metals won't be a problem until you get to a very low pH, right, when they become water soluble, right, and they absorb in the water. So most of those things in soils are not a problem either. Plants will not choose to eat lead. Plants will choose to eat organic material, and they'll particularly choose to eat colloidal humus, colloidal material. Right. So if you've got your pH scale, 7 is in the middle. Do I like green for the people at the back? 7's in the middle, and it's indicated as green. And 6 is going a little bit acid, and 5 more acid, 4, 3, 2, 1. And then the alkalinity is usually indicated in blue. It's 8, 9, 10, 11, 12, 13. Now, it's a strange scale. It's a logarithmic scale, so it needs a little bit of explanation. It's to the power of 10. So 6 is 10 times more acid than 7. 5 is 100. 4 is 1,000. 3 is 10,000. 2 is 100,000. And 1 is 1,000,000 times more acid. And so, yeah, but by the time you get it there, don't worry about life systems. You're well and truly gone. This is sulfuric acid. This is, yeah, you could talk about where it goes in extremes, but life is in here. And if you're talking about a water tank, you can't even hold the water in something like there. But, so, you go in 10. Same, it goes the other way. And if you want to correct alkalinity, flowers of sulfur will correct it. So when you're out in the desert, you want to grow your citrus tree, which will grow in the desert, but likes a little bit of acidity, doesn't really like alkalinity. You need some way of making the desert a little bit more acid. So a little bit of sulfur will speed that along for you. Or some method of making it more acid. Deep mulches will always move alkalinity or acidity towards neutral. And you'll find in a lot of deserts, there's a lot of pine trees. North American deserts are full of different types of pines which have acid mulches which correct the alkalinity. So flowers of sulfur here will correct alkalinity. And lime here, that's why limestone, the calcium in the limestone, lime or dolomite, calcium carbonate, magnesium carbonate. This adds a little bit of magnesium as well, the dolomite, so it can be either. But and our gardens are best here at about 6.5 is a great sort of garden, just on the acid side. Good garden there. But it doesn't really matter. Anywhere somewhere in here is good. A lot of rain is about 6.2. It's about there. A little bit acid, carbonic acid, 6.2 rain. Let's get the carbon from carbon dioxide in the atmosphere. Makes it carbonic acid just a little bit. Our life zones sort of come out here somewhere, and that's it. They're gone. There's not much outside of here. When you get to 4.5, there, something particular happens. At 4.5, heavy metals dissolve and become water soluble. So there your lead dissolves and you can drink it. Now you're in trouble. Zinc dissolves, cadmium dissolves, mercury dissolves. You get Mad Hatter's disease if you start taking in too much mercury. Cadmium, you don't want to know about cadmium. The government doesn't want you to know about cadmium. They did tests in the 70s on agricultural produced crops in Australia and put a D notice on it because of the amount of cadmium in synthetically fertilised food. That's the same world over. If you die of cadmium poisoning, it's a very painful death. In Japanese, it's called itai itai. It hurts, it hurts. Yeah. Sorry? Minamata? Oh. Oh. There you go, we're getting direct reference here. Because your synthetic fertilizer is based in a cadmium salt, usually. To make fertilizing elements for plants that they drink and don't eat, you have to base it in a salt to be stable. Otherwise, it has to be a humus or a compost. How do you stabilize something that's like an organic fertilizer? It oxidizes away from it. All the goodies that feed the soil, right, all the nice sort of cake and cookies with a soil life, are all things that sort of go putrid and smelly. You know, fish, manure, you know, dead animals. All those things that are high in nitrogen and have lots of interesting elements, they all kind of go putrid and dissolve and rot away from you really fast. You have to stabilize it. That's what compost does. It stabilizes it in the carbon. With synthetic fertilizer, those elements are chemically stabilized in a salt, and it's a cadmium salt. So you have a large amount of cadmium in your food, more than you should. But it means you can throw on this sort of salty looking stuff and wash it into the soil, and it is water soluble, and the plants have to drink because they are hydraulic. So they have to take in the water with the fertilizer in it. It's force feeding. But let's get back to this. Your heavy metals are there, and that now is where you take up at 4.5. And a lot of cars, a lot of cities used to pump out lead in fuels, and roads that have 1,700 to 2,000 cars a day going down them, downwind from those. You can get quite a lot of lead toxicity still residual in the soil. And if you get dips of pH, rain coming down at 4.5, that lead is water soluble, can be taken up by the crops, and then you'll take it in. And lead gives you schizophrenia. Our cities are saturated with it. Now, it won't damage you until it's water soluble. And then it's a problem, because you're mostly water. So you'll take it in. But if you go one bit down from here, this is the real exciting one here, at 3.5. That's the one you've got to worry about. We can get over that bit of schizophrenia. We'll clean ourselves up over a period of time. But this one, you won't get over this one. At 3.5, aluminium, or if you're talking to an American audience, aluminum, right, becomes water soluble. And all soils, nearly all soils, have some aluminium, a small amount. You only need a small amount. Aluminium oxide or aluminium hydroxide in the soil. And that is 100% plant poison. And all plants will die. And this is acid rain. That's what they mean by acid rain. Plants or forests, ecosystems can take it for about 20 minutes. The trees will gasp and they'll buffer alkaloids. They'll put out alkaloids to compensate against the acidity. But after 20 minutes, they're gone. They will die. A big forest may take 5 years, but it will die once it's taken in enough aluminium, soluble aluminium. And that's what's happening that's what's happened in the Black Forest in Germany, many places. Downwind from industry, downwind from power generation, car exhausts in the long term, but particularly heavy industry. The European industry blows into Scandinavia and knocks out their forests, so knocks out another country's forest. They can't lime their forests to an economy that makes it worthwhile to produce forest anymore. The cost of liming the forest to buffer that much acidity knocks out all the economy of the forest, so you've got serious problems. But the biggest one you'll find is this one. This one. This is the biggest acid rain. Electricity. Well, you know, at the other end of this, what seems to be quite an innocent, clean power, there's a coal-fired generator pumping massive amounts of sulfurs up in the air into our biosphere. And it's creating acid rain. You'll find really clear-thinking permaculture people going off, switching off lights everywhere, annoying the shit out of people, because we all seem to think we have a right to put that electricity on. But I don't know how many lights there are on in this room, but there's probably 30 by the looks of it. It doesn't make it a very intelligent place, really. There's a sun shining out there, although it's a cloudy day. We could design this room to definitely light itself. But instead, we're sitting in here feeling quite clever, but we would not sit in this room if the generator was in here. So you're just pretending it's not happening. The consequence of the lights we're sitting in now, we would not sit with in this room. Edward de Bono made a statement, and he said that all polluters should be downwind from their outputs or upriver, and we'd start to clean things up. You should sit in there with it. And it, you know, all these little desk lamps and everything, they're all somewhere. What is generating that centralised power? It's either oil, it's fossil fuels of some sort, oil, coal. It's nuclear power, which, you know, we haven't got an answer for the waste. I mean, you know, that's not an answer. Some places it's hydro, but not in many places it's hydro. So we've got to rethink that, you know. You will always have pollution while you have centralised energy systems and gross national product. Production for the sake of production to get an economy, you know. Especially now we've taken it global. So while you have gross national product for the sake of an exchange rate, you'll always have pollution because people will produce just for the sake of that. And while you have centralised energy systems, you'll always have pollution. You can buy Sunrise Australian rice in Jordan half the price you can buy it here. You can buy New Zealand lamb in Jordan half the price you can buy it in New Zealand. But you can buy Ecuadorian bananas where we grow bananas in Jordan cheaper than we grow bananas. It's the same everywhere. Everything that's produced is cheaper on the other side of the world with a global economy. So you'll endlessly pollute the planet because you can't sell anything in Melbourne you produce in Melbourne for a profit. You have to send it to London. Neither do I. And none of us get any decent food either. It's all, you need food miles. You need to energy audit your food miles. New Zealanders do it really well. The New Zealand permaculture groups over there did some great research on food miles. And you need every single bit of food mile documented. And you'll come up with some very interesting things. New Zealand yogurt, you know, is made from New Zealand cows, but the plastic that the yogurt container's made in comes from an oil well in Saudi Arabia that someone processed in Hungary and sent it as a plastic. And then the little bit of metal on the top comes from a mine in Brazil, and it was, you know, made into a little foil in America and shipped into New Zealand. And when you actually add up the, you know, food miles on a New Zealand yogurt, it's about, you know, 12,000 kilometres or something, you know. There are these interesting energy audits we can do on our food in relation to the miles they've done and the pollution they're responsible for. So those sort of things, all that will carry on doing this. And what you get here is large amounts of tree death, and whole species drop out. So as you notice whole species dropping out, you'll know this is getting more and more serious. All the elms died in Europe. All the chestnuts died in America in the 70s, chestnut blight. You're getting all the pandanus dying on the coast in northeast coast of Australia, and it's outfall from coastal towns and the acidity blowing back off the ocean. In Europe, when the Dutch elm disease took out all the elms, what everybody did, all the researchers did, was they looked at what was carrying the disease, which had always been there. This disease had taken out a few elm trees before. It didn't suddenly arrive. It was carried by a little beetle that got under the bark, and this elm disease was carried around by this little beetle. So what we did was we attacked the beetle. We didn't stop it, and all the elms died anyway, but just before the elms died, we threw a lot of poisons around on these beetles and nearly wiped out the beetle, but didn't quite. A few elms, just a few, are regenerating, so we haven't completely lost the elm, but we lost all mature elms in Europe, absolutely all of them. The beetle wasn't the problem. The Dutch elm disease wasn't the problem. This was the problem. Those elm trees gasping for breath against the acidity reduced their immunity system, so they became weaker and weaker and weaker. The symptom was Dutch elm disease. The symptom was carried by the little beetle. If you keep treating the symptom, you never treat the cause. This is the cause. And this is acid rain. And the higher up you go in altitude, up into mountains, where you get a lot of precipitation up in the snow, this is where you'll get really high acidity or very low numbers in the acidity. This is where in Vermont we measured 1.8 in the snow. Good job it was in snow. That's rubber clothing material. It gets pretty kinky. If it's rain, you can't walk around in normal clothes. It's going to melt your clothes. This is battery acid, getting down to battery acid type stuff. It can rain anywhere in the world now at 3.2. You get clouds anywhere. It could rain right here. It's got to rain for a little bit of time. There is this much going around, especially with the increase in cars. So we know we just can't carry on with that. You can't carry on with that behaviour. And you'll come across it all over the place. It's not as serious as soil erosion and the deforestation, but it is something we're going to have to address. Acid rain. So while you've got your water tank in here somewhere and you've got your block of limestone in there, it's adjusting that pH. And on the outside, there's an interesting thing. When you look down on your water tank, just inside the water tank, when it's nicely set up, there's a little film, a little green furry film of algae just hanging on to the inside of the tank. That's great. That's what you want. Don't look in and go, oh, it's all a little bit green and slimy. It's not. It's just a few millimetres out from the edge. That says it's nice and healthy. And if a little bit of, there's going to be some birds perch on your roof, and they're going to poop here and there. Sorry? And if you're keeping pigeons, you've got to be careful. You've got to put wires up on your roof line and on a little wire along your roof line, wire along your gutter edge, so you discourage them from perching on your roof, because you've got a rather large amount of birds now flying around. If you've got pigeons as a system in your garden. And they have strong manures, so you can't have too much. But just the normal amount of manures that may fall on the roof and other organic materials, when they get washed off, a little bit of manure lands in the tank. If you watch what happens, it immediately gets sucked out to the side, and it gets eaten by the algae. That's what the algae is doing.
My local council has regulations about water tanks, and you're supposed to remove all that algae. And legally they can come and inspect your water tank and direct you to remove it.
They probably, this is New South Wales, yeah. They're always doing this in New South Wales. They over-regulate everything and then can't police it. There's probably not a water tank inspection officer.
There is actually. They do septics as well.
They do septics? What do they inspect in a septic? It's not algae. A septic doesn't work unless you've got, organisms in there.
They come because most of our local government areas on septic. So they employ two people to come and look at your septic. They charge you $35 to come and look at it and say that's a septic.
But these, if they want you to drink this water, you need to have that algae in there to take out the little bits of organics. It eats it. Right? If you get in there, you can get in there and bleach it. After a while, after a long while, a tank gets with the water coming off the bottom. It gets a certain amount of detritus matter in the bottom, just coming below the tank, and you may have to empty that out. And there are companies that come and take the water out of the tank, put it in their tanker on the back of their truck, and then take this little bit and clean the bottom of the tank and then put the water back from their tanker. But you should really do it quite quickly and leave the algae on the outside. I'd check on that, and that's good fun. It's really great to design with lots of restrictions. Give me 10 health inspectors, 10 building inspectors. Give me all the restrictions you can possibly put on me, and it makes my job really easy as a designer. It makes it much easier to design under restrictions. The hardest job you'll ever get to do is when you go out, and it'll often be on an aid project, and they'll ship you into a large job, and they say, here's all these people, they're in big trouble, here's a huge block of land, do it. Do whatever you have to do. And there's no brief. As people put a brief on you, the more restrictions there are, the more you have to work out, okay, it's easy, we can't do that, we can't do this. We've got this health inspector coming along saying we've got to take the algae out of the tank. Oh, great, that's great, because I know that Geoff said the algae's doing a good job. So that's obviously something I could look up and research. And now I can go to the health inspector and say, why? Why am I having to take this algae out? Because you have a duty of care. You are in a developed country, and all those government officials have a duty of care. There is a Duty of Care Act, same as with the fire inspector. And you can turn around and say, okay, that's fine. If I get ill from taking that out, I'm going to put the duty of care onto you. You're responsible for my health because you're regulating me. I'm passing it on to you. But I have the research that says this is, and I Googled it. You didn't, right? And it says the algae does this. Right? Algae is a very clean product. It's a very base life form. This runs on sunlight. If you cut the sunlight out of the tank, if you don't have that little hole, that Australian tanks have a hole with a mozzie net mesh over there, or just a mesh to stop the mosquitoes getting in. That little bit of light getting in there will create the algae. Right? And algae is phytoplankton. It's plant plankton. Right? And it grows on the breakdown of organic matter that is inevitably going to drop in your tank. Now, if you don't have the light, you don't have the phytoplankton, you don't have the breakdown of the organic matter, you have an anaerobic decomposition system, and you don't want that. So we can now go to them and say, well, this is the reason we've got the algae, and I'm passing the duty of care on to you. And then you have a liability situation. He will immediately pass it on to his superior. And if he's feeling a bit dodgy about it, he'll pass it on again. And it'll just keep going. And it's the same if you get a problem with the fire department. It's a good thing, the Duty of Care Act. At Tyalgum, I came back one year from working overseas, and I've been working in the Amazon, and I've been working in some pretty bad smoke and fires, and the tip was burning at Tyalgum village. The landfill tip was burning, and we had a tip that was going to be shut down once the landfill was full, and it was going to go onto a container tip, garbage tip, and they were going to be shipping the material away, and there would be some degree of recycling. But the local farmers, the local rednecks in that area, they wanted to keep the landfill tip because they could dump cars and different things there. So they kept setting it on fire, which would reduce the volume. And the tip was, there was a certain amount of, runoff from the tip that was coming into the local streams, and the normal bad problems with landfill. But the fire was mostly plastic smoke, and I have a real aversion to plastic smoke. I don't give a shit what you do with plastic. I've got fed up with it. I've had it up to here on projects talking about plastic. It's something that really makes me sick. But I don't care what you do. I don't care if you mulch your garden with it. In my house, you don't throw plastic around the garden, but if you want to do it, do it. It's just particulate matter. I think it's highly disrespectful, but don't burn it. If you low temperature burn plastic, you get these long, sticky molecules that stick in your lungs, right? And it's quite carcinogenic. And I really don't like to see the innocent kids playing in plastic smoke. If you know better and you want to do it, fine, but it goes globally aerosol. And when you look at the figures of how much plastic is being burnt globally, it's a horrible nightmare. We're just not looking at the responsibility of what we do with plastic. So here I come back, I've been looking at burning piles of plastic in South America and trying to tell people, whatever you do whatever you like with it. Don't burn the bloody stuff and let kids play in the smoke. Kids seem to like, we've all maybe done that, melted plastic and watched it burn and go zip, zip, zip. Yeah. So I came back and there's this plastic fire, this smoke and it's going off from the landfill tip, and there's this line of smoke going across the valley, and it's settling out in the valley, in the village, on the school. And I'm just not having it. So I'm on the phone to the fire department and I said, look, the tip's burning. Get the fire brigade out here and put the tip out. And I said, oh no, we can't send the fire brigade out from Murwillumbah, it's too far, then maybe the special unit would have to come from Tweed Heads. We're right at the bank of the Tweed Shire at this, where Tyalgum. So I'll send the CFA, the Volunteer Fire Brigade. I said, look, some of our staff members on the farm were Volunteer Fire Brigade, and they got no breathing apparatus. I said, oh no, hold on a minute, they're volunteers, they've got no breathing apparatus. He said, oh, I can't help that. Well, I'm talking to a fireman. This is an emergency number, and this is being recorded. I said, well, hold on a minute. I know this is recorded. What's your name? What's your rank? And I'm passing the duty of care on to you. If you're going to send volunteers to breathe in toxic smoke, you can take responsibility for it. And he said, hold on a minute, I'll put you on to my superior. So I got the superior on the phone, and he passed me on to the area superior within a couple of minutes. And in the end, we got the full fire brigade out there with the breathing equipment, and they put out the fire. It did take them quite a long time because it starts burning underground. They didn't like it. I happened to have been informed about this by someone who was working with us who was an ex-fireman. But pass the duty of care on to these people who are telling you to do stupid things. Right? Because you will get over-regulation for the sake of picking up fees, often not policed, But yeah, we're either in the over-regulated world or the under-regulated world. Yeah.
Geoff, I had a question about the collection of rainwater from your roof. I can imagine that you have to inspect regularly for dead animals in your gutters.
Yeah, you can. Yeah, I've found sort of, at times I've found sort of, half-rotten rats and stuff like that have got caught up in drain pipes, and especially if you've got a downflow and a backup. There are all sorts of things. There are simple tip buckets and there are simple collection buckets, and there are simple ways to tip the first flow of rain off a roof. That's not a problem. But yeah, if you've got dead animals, surprisingly, again, the algae takes out all of that, or most of that organic material. I mean, not a large dead animal, but a large dead animal is pretty obvious, doesn't fit in the gutter. I have a 20,000 gallon tank, an 88,000 litre tank on my farm, 300 square metre roof. And I did find, some, a rat half decomposed not in the gutter line, in the downpipe line, and the tank was sort of 3/4 full, but it didn't affect the water because it was a reasonably natural tank. But yeah, when you know the value of water, yeah, you're going to check your roof, you're going to check your gutters, you're going to check the function of your tank because it has that much value to you. We're going to get into the prices of all these things as well. It is of great value. Yeah, you can look. There are if you are keen about these things, like when you're keen about mulch, you find a way of finding it. You find a way of producing it. It's just that we haven't had the focus. There are quite simple things. You'll see them drawn up in the manual. Downpipe comes like this. Downpipe comes like that. This is a mesh like that. The water goes straight through there, and the leaves and everything else and the dead rats fall off. It's just a gap with a mesh cone, and the water coming down goes straight into the slightly larger receiving pipe, and the mesh cone sheds off everything. It's as simple as that. There are all sorts of fancy tip buckets, but there's a real easy one where here's your downpipe, and it goes to the roof like that. It goes to the tank like that into your big water tank. But this is a dead end pipe, and here you can either have a tap. If you're regularly home, you can switch it on when you have to, or you can just have a dribble pipe. It's just a little hole in the bottom, and the water, when it comes off the roof, first goes straight down there, and when it's full to there, then it goes in the tank. And this just dribbles out of here and empties itself, and you put that to a garden. And if you want more of if you want a larger one, then you put an elbow on here and put a longer one like this, or a little tank, and dribble it off. So you can choose how much water you displace in the first part of the rain. And you can block it if it's raining regularly so it doesn't dribble. If you're in the rainy season, you feel your roof's well and truly washed. And there are other things you could do. You could then put filters on the tank. If you want to, you can put a filter off from the before you take off the water. But some of these laws, they should be, we should challenge them, because often people don't, because they haven't got an interest. We have this thing, I call it RAS. And we seem to be faced with it all the time, and we should challenge it. Rigorously applied stupidity is true evil. So let's have a look at the water on Earth. on a global scale, we have and the great blue planet. Of all the water on Earth, 97% is salt. Only 3% is fresh. Out of that 3%, of that 3%, 75% is in ice, in glaciers and ice sheets. So only got 25% of that 3% left. And then we have the interesting bits. You have 11% is rechargeable groundwater. That's less than 800 meters deep.
That's 11% of the 25% that is.
Yeah, it's 11% of that. 11% of the 3%. That's rechargeable if we're doing the right thing at the surface. And that very much involves the right water harvesting at the surface. That involves taking the longest path over the most distance, over the most time, with the most passive friction. Soaking it in with swales, little water ponds, soaking it into forests, not removing forests, not removing water, natural water systems, and definitely not running it off huge amounts of hardware into drainage systems that go as quickly as possible, as straight as possible, downhill straight at the ocean, which is generally what we seem to be doing. We seem to be runoff maniacs. We seem to compact everything, flatten everything, make everything in the hardware and get rid of the water as quick as possible. That will not recharge the groundwaters. So we are not doing this. But there is 11% of the fresh water in a situation that is not too deep. If we were behaving properly or harmoniously with the way all the systems do work, we could be recharging that. Then you've got 14% that's in deep groundwater, and you can't recharge that in the foreseeable future. It's way too far down. A lot of it is prehistoric water. Unfortunately, in America, as a technology, or as the power that's leading the world with, and a lot of countries are following the example, there's been a sort of a pump technology. It's something around the oil well type of pump everything from underground type of attitude, and that technology is pretty advanced, and we can pump that water, and you can deplete aquifers extremely fast. So the Ocala aquifer underneath America is going down at about 1 meter a year, and it's recharging at less than 1 centimeter. And that's holding up the global price of wheat. So when you start to look at the main foods of the world that are held up with this water, right, you'll see an interesting thing happening. You'll see the main foods of the world depleting in diversity. 1960, there was 12 main foods traded in the world. Now there's 5. And as you see it go to 4, and as you see the prices of main foods go up, you'll know that we're in a more worse situation. As you see the price of main foods go down in price and increase in diversity, you know we're going in a good direction. We're going in a more positive direction. And maybe we'll get back to where we were about 45 years ago and get back to 12 main foods. That'd be wonderful. It'd be great. But now we're just eating soy, rice, maize, wheat, and potatoes. Sugar's not a food. Sugar's a drug. You can drink to that. That involves quite a lot of sugar. Quite often. You have to be careful what you can drink in sugar.
What were the other 7 that price of 12?
Sorry?
What were the other 7 that price of 12?
Now you're asking me a detailed one. There was sorghum, millet, sago, cassava, barley, and all those sort of things. It was quite a diversity of stuff, and it went across quite a few climates. And they're just not traded anymore on the stock exchange. They're gone. Lentils, probably. And this one's held up with that aquifer. And also, we're trying to turn the Chinese into bread eaters. And the Chinese population can eat the world's supply of wheat 3 times. All the wheat in the world that's produced in 1 year, they can eat 3 times. So I don't know what we're going to eat. We're probably going to eat soybean bread. Because scientifically, it's much better just to, whereas we'll just all just eat soya, which is really the nastiest one in there. It's the nastiest little thing. This one's the one that probably should just, it's great. It's culturally integrated into all sorts of foods and agricultural systems in Japan. But as an industrial agriculture, this is extremely nasty. A lot of it was the first, of course it was the first one to have a complete patented soybean, Roundup ready soybean. Of course they would do that first. You see, Henry Ford promoted the soybean so you could have different coloured cars. Synthetic cellulose. So, you know, to produce cellulose, this soybean is very, very convenient. And you wouldn't really grow soybeans in most situations. Sitting underneath the persimmon trees on the buns of the rice paddies in Japan, making all sorts of interesting ferment products, yeah, great. But thousands and thousands of acres of this little leguminous plant, no. It's a legume. It's got a certain amount of self-fertilization. It's very genetically engineered now. You can produce cellulose from it as an industrial product. You can produce a little bit of extra as food. It's used to feed factory animals. When the fisheries in Peru collapsed, the great fisheries in Peru were feeding mostly factory farmed animals. In Europe, when those fisheries collapsed, the whole feed industry for factory farm animals went over to soy production. If you were going to grow soya, you'd plant an acre of soya. You want to plant 2 or 3 acres of firewood so you can process the damn stuff. You know, if you want to get vegetable protein from a bean, azuki beans would be a lot easier. You don't need to process them anywhere near as much to make them edible. And the ironic thing is, it's almost like a comedy. Right? It's sold as a health food. It's not healthy for this planet to grow soybeans the way they're grown. It's one of the most unhealthy activities globally. And when you see this, usually it's deep groundwater pumped into arid landscape to grow soybeans. The economy is so good, you pump and pump and pump and pump and pump and pump and pump, and you salt the landscape up with all the evaporation off the pumped groundwater, and you keep washing that groundwater through because of the economy in the mass monoculture agriculture that you've got, the soya. And you keep washing the salt through and washing the salt through, and you wash it to the lower layers, but it stacks up and stacks up and stacks up and stacks up. And when it's 20 meters thick, you walk away with your money. Switch the pumps off and leave the land to the local people who probably had a reasonably healthy desert culture there before. And now you have 1,000 years before that land will recover, if you start trying to recover it, which no one can afford to do. So you walk away from a salted piece of the planet. So that's, you can see this stuff all over the place. You can see soybeans doing this. So that's not very sensible. And there are definitely more sensible things we could grow, and we could integrate soya into a more diverse situation. So where did we get to? We got 75% plus 11 is 86%, plus 14 is 100%. But we know that's not all our water, don't we? So these are roundabout figures. There's a small amount left that's hardly worth mentioning, and that's lakes, ponds, and surface water. Lakes, ponds, and surface water. It's 0.03%. We can definitely increase those by our work. And then soil moisture and forests. 0.06% is in our soils and our forests, trapped up in our forests. All those trees are columns of water with the water hanging from the leaves. Amazing. And our rivers, what we got? 0.03 in rivers. And our atmosphere, our weather, 0.035% in the atmosphere. The ones we can affect, is the rechargeable groundwater there. The lakes and ponds we can definitely increase. We can hold more water in soils. The amount of water in the rivers is constant. We just get it coming all at once or not at all. It's our choice. It's either flood or drought. If we do the right thing, it's a nice moderated flow.
Bill was saying yesterday about clearing trees at the top of mountains and resulting in the snow turning straight into vapour. that's influencing what's in the rivers, because you said the rivers underneath it are then dried out.
Yeah, and then a couple of years later you get 3 years worth of water in one day. It all comes at once.
Well, he was saying that the snow is going directly into the atmosphere.
Yeah. And then you've got erratic situations. So all of a sudden you get a massive pulse of water, or you get it slightly displaced somewhere else, slightly different in the landscape. But the total rivers at the end, what you've got is you've got a constant amount of water in the system. It doesn't change. The water does not go anywhere. It doesn't disappear. It's in the biosphere, travelling around. Right? So the amount of water there's constant, but it's going really erratic. Right? So you're getting big floods, big droughts, big variations. You could moderate all this by doing the right thing. Right? By behaving the right way, you'd get the rivers flowing all the time at a nice moderate rate with very small amounts of drought effect and much less flood effect. The same with the atmosphere. You can get much more constant weather. So things get a lot more moderate. And we're seeing now extremes of weather. You're getting more severe storms. You're getting more severe droughts. You're getting stronger winds. You're getting lower temperatures and higher temperatures. So this is what we have to do. We have to look at these. This is quite a big one. But these very small figures here, it's a very fine line what we're dealing with here. It's a very small amount. It's very vulnerable. It's very easy to take it out of balance. So we have to look at the duties of water. What are the duties of water? And we have to think very carefully about how we design water into landscape. And the first thing that the duties of water is to create life. We look at water as a system that procreates life. And then aquaculture itself is looking at water as the system, not just the additive to the system. Life in water is very efficient. Life in water has the added advantage of not having to fight gravity. So things float in water, and the larger animals are not fighting against gravity. It's not like cows when they're having to walk uphill and use all their energy to move all that material around. Like ourselves, we're continuously fighting against gravity. That absolutely constant energy. And gravity obviously has a huge effect on water. And it's an energy that I often talk to people. It's just, you don't take that. Only 4-year-olds keep doing that. You're less than 4 years old, you keep wondering whether it's going to go up. And then you stop, you know. So you'll find that the most productive protein in area will be in water. The most productive food crop by weight is a water crop, water chestnut. Chinese water chestnut is the most productive crop by weight in the world for area. The fastest growing leaf crop in the world is a water crop, a semi-aquatic, related to sweet potato. Kangkong, Ipomera aquatica. You hardly have a meal in Vietnam without kangkong in it. It's a registered weed in North Queensland. Strange. Food that's a weed.
1 ton of biomass a day from kangkong, 40% protein content.
On what area?
On 1 ton per hectare.
1 ton of biomass per hectare.
A day, yeah, 40% protein. So for forage, for animals, it's just incredible. Animal food, and we can include ourselves in those animals.
Yeah, it's much better for you than lettuce as a green, and yet people try and grow it in the tropics where it grows like a weed, as they know in North Queensland now.
What was that?
Kangkong.
Kangkong.
Yeah. Ipomoea. Which is the sweet potato. OEA. Here. All right, thank you. Ipomoea aquatica. Ipomoea botatus is sweet potato. Ipomoea aquatica is kangkong. You can buy it in the supermarkets here now. It's got different names that they put on it. You can buy kangkong in the supermarket, take it home and plant it. It'll grow straight from the cuttings. Done it many times. It's very, very fast. It will actually float on water. It will come off banks and float on water. Islands are established with it in parts of Asia. You know, you stick out a few logs, tie them together, put a few branches, a little bit of soil in there, throw on some kangkong cuttings, float a few coconut husks in there, and it starts to stabilise this mass, and you get a floating island, a few coconut husks in there, and you actually start to get this floating island formed, mainly formed by kangkong. And some places in areas of big seasonal floods, they'll actually float something off like that, and as the flood goes down, they'll sort of like tie it off on a spot and let it sink down onto the ground as the flood goes, and then carry on gardening in that spot. And with kangkong as a ground cover. It'll grow on wet ground as well, or reasonably well-watered ground it will grow on. Now it's the fact that it's floating and it's putting these anaerobic roots out and taking nutrient from the water itself. But it's interesting that it's all the main large productions come from water, where there's this assist that they're not fighting gravity. Fish have swim bladders. Fish are very efficient. A lot of the fish that we produce, you could put them in a tank, a purge tank, and not feed them for 6 months, and they wouldn't lose weight. They just sit there. They go kind of dormant. Okay, and the other thing is to develop energy. So, energy systems. Power production, mechanical takeoff. So you can trip the water over different things. The idea is to use water as many times as possible. If you've only got 100 litres of water and you only use it once, you've only got 100 litres of water. If you've got 100 litres of water and use it 10 times, you've got 1,000 litres of water, really. You've got 1,000, you're using water as if you have 1,000 litres of water. And you need to use water to increase life in systems and to increase potential yields. So we can increase surface storage. So surface, we can do all sorts of lakes and ponds and forests and systems that hold water up high. That's what I put, surface. I must find it hard to talk and write, I think. Storage. And we need to go into the details of those. What are the shapes and how do we go about it and what equipment and how does it fit into different landscapes. And we can reduce the runoff You look at runoff, you look at hardware. It's that big rock mentality we were talking about in the arid zones. You look at everything that could be running off water as an opportunity. What could I do with that? Where could I direct that? How could I hold that up as high as possible? How could I soak that into something that will grow from it or live from it and fill tanks and ponds and different things? And we can decrease evaporation, which we talked about in deserts, but it works everywhere. All of those things will make design more productive. So soaking water in, we need to condition the surface of the land so that water soaks in. And if we've got the landscape that's already forested, it's doing quite a good job already. But a lot of the land that we're working on, it's cleared, it's damaged, it's compacted, it's eroded. Right? It's more or less been set up in a condition that runs water off very quickly. It doesn't soak in. Water's open to evaporation. So we need to sort of condition the surface so that we start a positive process, so we start the land to receive water. There's a great tool that fits on the back of a tractor called a Wallace plough, and there are variations of Wallace ploughs, and it's got a set of tines, but it's what you need to know is the concept of why this works well. And there are different variations of these, and fits on the back of the toolbar of the tractor, and it leaves a rip that doesn't turn the soil. It just leaves a deep rip, and you'll just see it looks like the surface of the soil has been combed like this. And not only the surface is more receptive to soaking water, but air gets down, right? And they're underneath compacted ground, especially where you've had continuous grazing. The animals have been going across the ground, and they've been cutting off the pasture or the herbage at a regular level. And it can also happen if you're regularly slashing, especially if you're taking off the material and not building up the slashed vegetation. And the root zone gets limited because you're always taking off the top. So you don't get any deep rooting plants, and you don't get any pioneers taking down big roots that might decompact the soil. Everything's clipped off by the grazing animals, compacted at the surface, and you'll get a hard pan underneath the root zone. And because the clays are the fine materials in the soil, the clays are the most fine, they'll gradually slip through, wash through with the rains down, and you'll get a clay hard pan here underneath the root zone, and that increases the runoff, reduces the surface storage, and holds the water up in this top layer, which increases the evaporation, the opposite to what's happening, what we're saying we should do. So when you go through with a Wallace plough, you break right through this without much disturbance at the surface. Right? And you get air coming down into the soil, so you get more air in the soil. You get more water infiltration into the soil. That increases the life in the soil, so you get more life in the soil. You get a better temperature down in the soil. All of that increases or improves the pH of the soil. And it generally starts to improve. So what you've done is you've taken this perverted landscape, there's been some sort of perversion happening, right? And you've conditioned it to start a process. You've speeded up what would have happened. If you'd taken those cows off, there would have been pioneer trees coming in here and shatter that clay pan. There would have been deep-rooted pioneer weeds that would have broken through. And then they would have gone through their lifespan and their roots would have rotted in the soil, and slowly it would have come into this quite aesthetic conditioning over time. But we're usually in more of a hurry than that. We want to improve our land, we want to get on the land, we want to start the process. So we need to look at this sort of concept of conditioning the surface of the land so that it can start a repair job. But we know as designers, that's not the end of the story. What kind of pattern do? You don't just plough up and down hill, because it could start... Yeah, so we generally start to think on contour. Right? We start to think about, okay, we don't want water running really fast downhill, we want to hold it up. And P.A. Yeomans wrote the book Water for Every Farm, and it was the first time anybody really wrote a book about designing agriculture, amazingly, in the history of mankind, really. It was the first real book on agricultural, whole landscape agriculture design. And he mainly just designed water, mainly for grazing systems. So he designed one main element across the landscape, particularly for grazing, and he designed it to receive water, because he obviously realised water was the main element. And we've taken that whole thinking quite a bit further, and we've put it into tree systems. We've integrated all of these type of concepts. And what we need to do now is we need to start talking about a little bit more detail about key line. Not that we need to be real key line experts, but we need to understand the concept of key line design so we can think that way in design planning. Right? So that's what we'll do after the break. As far as, you're going to apply design over such a broad, holistic sense, the variation between one good tool and another good tool in the end game is not going to make much difference. Being exactly on key line or knowing a key line exactly, knowing biodynamic processes exactly. Biodynamics, life dynamics, tell me about it. I mean, the systems we put together are incredibly biodynamic, and we do all kinds of things on key line and contour. We're so holistic and integrated, and a lot of that stuff is kind of, don't need to get that fussy. It doesn't matter. We're going to go on the permanence. We're designing permanent, really abundant, sustainable systems. So, Wallace plough, Yeoman's plough, biodynamic, organic, biointensive. It's all in there. Doesn't really matter. You'll find it all. Let's go. One.